At this point, I assume you have watched my first video, part 1 of Lewis dot structures. So this is a continuation of the same discussion. What I'm going to do is I'm going to discuss a couple of more examples and then discuss two simple topics: resonance structures and bond polarity. Okay, let's start. Let's start with this molecule, a simple molecule. So we are going to write the Lewis dot structure for HCN. First thing, let's calculate the number of valence electrons. So carbon 4 valence electrons, nitrogen 5 valence electrons, and hydrogen 1. So the total is going to be 10 valence electrons. At this point, you need to know how we got these numbers. So now what we do is we are going to distribute these electrons throughout the molecule. So the central atom is going to be carbon, and there are two terminal atoms, nitrogen and hydrogen. So you create a single bond between the central atom and the terminal atoms. Each bond, each line is 2 electrons. So there were 10 valence electrons at the beginning. Now we used 4 to create those lines. There are 6 left. Then what you do, you take those electrons and go to terminal atoms, complete their octet starting from the most electronegative element. In this case, nitrogen is the most electronegative element, so we have to complete the octet, 8 electrons of nitrogen. So I can place 6 electrons as 3 pairs because nitrogen already has 2 electrons. If we place 6, octet is complete. So that is all we have. We don't have any more electrons. After that, we don't have any more electrons. There are 0 valence electrons left. But still, if you look at the electron count, if you count the number of electrons on each element, hydrogen is happy. Hydrogen has 2 electrons. So these 2 electrons belong to hydrogen, that bond electrons. And nitrogen is happy as well. Nitrogen has its 8 electrons. There are 6 dots plus 2 bond electrons, so 8. But if you look at carbon, carbon doesn't have 8 electrons. Its octet is not complete. At this point, carbon has only 4 electrons. These 4 electrons. So carbon needs another 4. How can we give that 4 to carbon? Just by making double bonds. So we can, just to make it clear, I will draw it again. Carbon does not have its octet. We have to give carbon 8 electrons. There are 4 already. We have to give another 4. The way I do that is I can take one pair of electrons and share with carbon. That will give carbon 6 electrons, but that is not enough. That means you have to share another pair of electrons with carbon. So 2 pairs. Once you do that, what you get is this. There was a bond between carbon and nitrogen. Now we created 2 new bonds because we donated 2 pairs to carbon. Not donated, we shared with carbon 2 pairs. So we created 2 new bonds. Now on nitrogen, there is only 1 electron pair is left. So hydrogen is, we did nothing to hydrogen. Now you can check the formal charges of these elements. Last time we discussed how to calculate the formal charges. So if you look at nitrogen, the formal charge of nitrogen is 0. Carbon, formal charge of carbon is 0. Hydrogen is 0 as well. So these are the formal charges. So that is the Lewis dot structure for HCN, and there is a triple bond between carbon and nitrogen. So this is called a triple bond because there are 3 bonds. So HCN is good. I assume you understand. Let's take another one. Let's take O3, ozone molecule. So there are 3 oxygen. Still we can follow the same procedure we discussed. So there are 3 oxygens, then there are 18 valence electrons. So this is oxygen, let's say that is the central, then there should be 2 oxygens bonded to this. So 2 lines, 4 electrons. Out of that 18 you used 4 electrons. There are 14 left. So now distribute those electrons on oxygen, on terminal atoms first. Okay. So there are 14, I can place 6 here, so that oxygen is happy. I can place another 6 here, so that oxygen is happy as well because it has its octet. So we used 12 out of 14, there are 2 left. Then what you do, you go to central atom and place them as lone pairs. Now if you look at the electron count on each oxygen, the 2 terminal oxygens, they have their 8 electrons, but the central oxygen, the central atom, it has only 6. Okay. I'm talking about this one. There are 2 bonds and 1 lone pair, so 6. So that oxygen is not happy. So we have to give that oxygen 8 electrons. How can we do that? Just by creating a double bond between terminal oxygen and the central oxygen. So let's give this pair, let's share that one. If you do, what you get is, initially there was 1 bond, we created a new one by sharing another pair with this oxygen. We did nothing to this oxygen. So now let's look at the electron distribution. This has 2 pairs now because we donated 1, we shared 1 with the central oxygen. There was a lone pair here, and there are 3 lone pairs on this oxygen. So now let's calculate the formal charges just to make sure. Terminal element, this oxygen, the formal charge is what? It is 0. If you calculate it using the formula we discussed in the previous video, it is 0. The central oxygen, the formal charge is +1, and the other terminal oxygen, it is -1, -1. So if you remember, in first video I said, if the central atom has positive charge, if you can, just try to make it to 0. But do you think we can make it to 0 in this molecule? The answer is no, because oxygen has 8 electrons in its valence shell in this molecule. So oxygen is in period 2. Oxygen cannot have more than 8 electrons when it is in the central atom or terminal atom, doesn't matter. So we cannot get rid of that +1 formal charge on oxygen. So this is the right structure for ozone. We can't get rid of that +1 on oxygen. I assume you understood. If you want, I can write it down just to remind you, but this was discussed in our previous video, the part 1. I assume you understand when I write it in that way. I believe it is clear. Okay. So let's do one more. Okay, so I have given you a molecule. I have given you the skeletal structure. So now our task is to write the correct Lewis dot structure for this given structure. The skeletal structure is given. The atoms are arranged in this way. Okay. So the first thing what we do is we need to know how many valence electrons. Let's calculate that quickly. There are 2 nitrogens. We know nitrogen gives 5 valence electrons, and there are 2 nitrogen, so total is 10. There are 2 oxygen. Each oxygen will give you 6 valence electrons, so total 12, and there are 2 hydrogens. So each hydrogen gives you 1 valence electron, and there are 2. So the total is going to be then, now you have to distribute those 24 in that skeletal structure. Let me write it down again. So this is the skeletal structure. So there are 5 bonds. So we created 5 bonds. That means 10 electrons. Out of that 24, then we have already used 10 electrons. There are 14 left. Now we have to distribute those 14 on the atoms in the molecule. Start with the most electronegative element, which is oxygen in this molecule. There are 14 electrons. We can give 6 to this oxygen. We can do the same for this oxygen. 12. There are 2 left. So I'm going to give that to this nitrogen. Okay, 12 plus 2, 14. Now we don't have any valence electrons. That's all we have. Now let's count the number of electrons on each atom. Let's start with hydrogen. That is the easiest. Hydrogen has 2. So hydrogen is happy. We don't have to do anything with hydrogen. And the nitrogen bonded to hydrogens, I'm talking about this nitrogen, let's say A, it has 8 electrons, 3 bonds and 1 lone pair. So that nitrogen is happy. If you look at the other nitrogen, let's say it is B, it has only 6 electrons. 2 oxygens, they do have their octet. So nitrogen, that nitrogen B is not happy. Everybody else is happy because they do have their octet or duet. Okay. Now we have to give that nitrogen B 8 electrons. The way we do that, by creating a double bond. So I'm going to take this pair and share with nitrogen. If I do that, I'm going to get this structure. So I will get this structure. So we created a so I will get this structure. We created a double bond between that nitrogen B and oxygen. So now everybody has their octet. So let's calculate the formal charge. Okay. So just make it a habit to calculate the formal charge once you draw a structure. Let's start with that double bonded oxygen. So that will have a 0 formal charge. Again, if you don't know how these numbers are coming, where these numbers are coming from, I want you to watch the first video and see how to calculate the formal charges using the formula. Nitrogen B, the formal charge is +1. Nitrogen A, formal charge is 0. The hydrogens, as you can see, is 0. This is 0, this is 0. The other oxygen, single bonded oxygen, the formal charge is -1. So we have 2 formal charges, -1 and +1. We cannot make that +1 on nitrogen B to 0 because nitrogen already has 8 electrons. We can't go beyond 8 electrons. So we have to stop here. So this is the Lewis dot structure for that skeletal structure I gave you. Okay, so far we have done several examples. Okay. So I think it is time to move on to the next topic. Next simple topic, resonance structure. I think this is a good place to start that.